So let's continue the separables rewind. My recommendation would be to go over the 2017 separable in context and try this one yourself to see if you can deal with the issues and understand the fundamentals of these type of problems. But let's break this one down. So in 2012, number 5, we don't get a calculator. We have the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight, right? So if you notice this is the separable, right? At t is equal to 0, the bird is 20 grams, so they're giving me an initial amount of what this thing weighs. And we know this is, if you look at the units, grams and then t days, so grams per day. So we should always kind of wrap our head around the units for the rate. Kind of puts my head into the right space. So here's my differential equation. So the rate at which the bird is gaining weight is proportional to the difference between its adult weight and its current weight, right? So they're telling me that once the bird hits 100 grams, it's going to stop growing. All right, that's kind of like a carrying capacity in a logistical model, but this isn't a logistical model, and those of you doing the BC also know that, because there would have to be a 1/5 times b here, right, and then multiply by the 100 minus b. But if you look at the graph that they're asking you to do something with in part B, this is a logistical model. So this isn't, though. And you're going to actually prove why from this. It can't look like this. All right, so let's go. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So again, you don't get your calculator. Your first move would be, and I would notate it as b prime of 40, which would give me 60, 1/5 of 60. I guess I can write that out. I don't have a calculator. 1/5 of 60, which would be 12 grams per day. Remember, that's the rate. At 70, so take b prime of 70, which is just the differential they're showing us there. So we'll take 1/5 of 100 minus 70, right, would be 30. 1/5 of that would be 6 grams per day. So this was a pretty easy first part. Don't overthink it. Use their words, write a sentence. The bird is gaining weight faster. When it weighs 40 grams, just look at your units carefully, because b prime of 40 is greater than b prime of 70. Simple as that. Pretty straightforward. All right, now here's where we got to focus. It wants us to find the second derivative, right, in terms of b. Make sure we understand that. Use that to explain why the graph of b cannot resemble this graph. All right? So watch this. And this is where, again, you just got to be careful. And I'll show you the mistakes students make. Now remember, the differential or the rate is determined by, it told you, it's proportional to the difference between its adult weight and its current weight. So I would distribute the 1/5 in. That would give me 20 minus 1/5 b. Now a lot of students would say, well, the second derivative is just negative 1/5. Well, b is actually the range value. It's the y value. So you have to implicitly take the derivative of that to get the second derivative. Now watch. So the second derivative would actually equal a negative 1/5 Not just that, times dB dt. But I would show, just because I don't have a lot of room here, I would probably just write it straight across. I would show them in terms of B, right? They don't want it in terms of dB dt. I would just go back up to here, and I would multiply my dB dt by a negative 1/5. That would give me a negative 1 over 25. All times 100 minus B. Cool. Now we can see that the bird started at 20, right? And it at most can get to 100, and it's just going to stop growing, right? It's just going to level off when the weight approaches 100. Why can't it look like this? Well, let's show them why based off concavity. Now, you got to dig a little deeper into how you plug into this thing, right? So for 20, less than or equal to the bird's weight, which is less than 100, right? Because this is going to tell us, that's when we know this differential is going to grow. The second derivative would be negative, right? If we plugged all the way up, not including 100. That would give me a negative second derivative. So the second derivative would be less than 0. The graph of B cannot resemble the following graph. Use their words. Because, and this was my thought, because the second derivative is, now watch me, greater than or equal to 0. God, is that ugly? I'm sorry. So the second derivative of B is greater than or equal to 0 on portions for t greater than 0. A little sloppy, I apologize, but you get the gist. Now this last part should be the easy part, right? You want to use separation of variables to find the actual b of t and then find the constant, right? And be good with that. So let's do that. So I would divide the 100 minus b over to the left. And that would be multiplied by dB. We're just separating. I'd leave the constant 1/5 multiple over to the right, and then multiply the dt over. We're going to integrate both sides, right, in terms of those given variables. Now I'm going to show this because this is a rewind. Just be careful. The integral of this is not the natural log of 100 minus b. There is an adjustment you need to make using substitution. Some of you can do that in your head as you're doing it. By all means do that. I'll just show it out. So u would equal that. My du would equal a negative dB, or negative 1 dB. So I would need to take a negative du to equal dB on my substitution, so when I'm matching things up. That means this would be in the form of negative square root integral of 1 over u du. So there had to be a negative adjustment based off of this. All right, so substitute. You can do that in your head, I'm sure. But the whole point is you should know that that's negative ln of the absolute value of 100 minus b. That's where you got to be careful. Equals 1/5 t plus c. Now remember, you can't exponentiate both sides until that negative is out in front of the natural log. So we need to multiply through by a -1. So that's be the ln of 100 minus b is equal to a -1/5 t. Now the c would just absorb it in this scenario, that -1. Exponentiate both sides as base e's, right? So this would be 100 minus b of t. And like some of you are saying, why are you not finding your c right away? My general rule on separation is find the actual function in terms of c and then go back and find the c. That's just how I do it. That's how I teach it. You do it your way. I've always found that this kind of minimizes mistakes. Now, again, you should know how to deal with exponentiating this side with the constant here using exponent rules. That would be CE to the -1/5 t. Should have learned that and why. Isolate your b of t, and that would give you 100 Oh, I'm sorry. Let's go up here. Oh yeah, sorry. We would bring the b of t over. We would subtract the CE to the -1/5. Finding the constant will work itself out in this case. I apologize. So that's how I would get my b of t isolated, right? But I know at b of 0 it's 20. So 20 would equal 100 minus c. I would add c over, subtract 20 over here. C would be 80. So my b of t would equal 100 minus 80 e to the -1/5 t. Now if you want to get all the points, we should show the restriction is t is greater than or equal to 0. I'm sure a lot of people don't put that, but showing that that is when t works, right? That's the domain for that. So hopefully that helps. Just be careful with that second derivative. Remember, this is considered the range value, so we have to chain out implicitly the dB dt, and a lot of students might forget to do that. So hopefully this helped you.